Hi, and welcome to Addition with Whole Numbers. We're going to start this section by talking about the number line and seeing how it's helpful to visualize addition. So let's say we wanted to start with the number 2 and we wanted to add 3 to that number. So we want to move 3 places, 1, 2, 3 up the number line, and we end up at the number 5. So this represents 2 plus 3 equals 5. So let's say we wanted to add 4 more to this number 5. So we're going to start here again. We're going to move 1, 2, 3, 4 places up the number line. We end up at the number 9. So this represents 5 plus 4 equals 9. So it's important to become comfortable with adding all of the single digits on this number line, 0 through 9, all the combinations that you can make. It's important to memorize those, and it'll make working through the problems in this section much easier. So first, let's kind of go over one vocabulary word that's important to know when we work with addition, and that's sum. So when we add 2 numbers together, the result is a sum. So let's say we were to assign A to one number and B to another number. We'd say the sum of A and B is A plus B. So you'll encounter that a lot in this section. Now, one other thing before we go through and work some examples, I wanted to talk about this first property, and it's called the addition property of 0. Now this means that when you add 0 to any number, you get that number. So let's visualize it on the number line. Let's say we were to start at the number 6, and we were to add 0 to 6. You're not going to move anywhere on the number line, you're just going to stay right there. And so your answer is 6. So visualizing it using these symbols for the property, if we were to give or let A represent a number, we can say A plus 0 equals A. Or in other words, 0 plus A equals A. So let's move on and let's work through some examples. For our first problem, we're asked to find the sum of 3 plus 5 plus 7. So let's go ahead and start at the beginning. And we're going to add 3 plus 5, which gives us 8. We can bring down what we have left and then add the 7 to the 8. So 8 plus 7 is 15, which is our answer. So we have 15 is the sum of 3 plus 5 plus 7. Let's do our second problem. Here I've set up these numbers vertically, and we're going to find the sum of 32 plus 21 plus 43. So we make sure that we do our digits in the correct column. We're going to work through our ones column first. So we add 2 plus 1 is 3, plus 3 is 6. Going over to our tens column, 3 plus 2 is 5, plus 4 is 9. And that's our answer. So the sum of 32 plus 21 plus 43 is 96. Let's do a couple other problems that involve carrying. Okay, so the problems we just worked through, the sum of the numbers in a single column was either 9 or less. We're going to work through some problems where the sum of at least one of the columns is going to be greater than 9, and we need to use the process called carrying in order to find our answer. So let's look at our first problem, 49 plus 16. If we were to work through this in our ones column, 9 plus 16 is 15. And we don't want to put 15 right here, and we need to figure out which number to put there in order to move on and find our answer. So let's write this out in a little different way to help us visualize. 49, we can write this as the same as writing 4 tens plus 9 ones. Now 16 is the same as writing 1 10 plus 6 ones. And let's do our addition with these numbers here. So 9 plus 6 is 15. That gives us 15 ones. And 4 plus 1 is 5, which gives us 5 tens. We can write 15 ones. We know that's the same as 1 10 and 5 ones. We bring down our 5 tens. We add the 5 tens plus the 1 10, that gives us 6 tens plus 5 ones. 6 tens is 60 plus 5 ones is 5, so 60 plus 5, our answer is 65. So let's go ahead and do this problem here, and we're going to work through it using our carrying process, and we'll see that we'll get the same answer. So 9 plus 6 is 15. We're going to put the number in the ones column here, which is the 5, and we're going to carry that 10. So we're going to put the 1 up there, carry the 1, and then we're going to add 1 plus 4 is 5, plus 1 is 6. So the sum of 49 plus 16 is 65. So we're not going to go through this whole process for every single addition problem that we do. We're going to use our carrying, which helps simplify it. So let's go ahead and move on to our next problem here and just use the carrying. So let's start with our ones column here. We have 5 plus 9 is 14. We're going to put our 4 here and carry the 1. 1 plus 0 is 1, plus 9 is 10. The 0 down and carry the 1. 1 plus 2 is 3, plus 9 is 12. Put the 2 there, carry the 1. 1 plus 6 is 7. Plus 9 is 16. We're going to put both numbers down there. So our answer, the sum of 6,205 plus 9,999 gives us 16,204. Let's move on. When working addition problems with whole numbers, it's important to note 2 properties. The first of which is the commutative property of addition, and this says that you can change the order of any 2 numbers in a sum and not change the result. So we can write A plus B equals B plus A. Now the second property to know is the associative property of addition, and this says that we can change the grouping of 3 or more numbers in a sum and not change the result either. So we can say A plus B inside the parentheses plus C is equal to A plus B plus C inside the parentheses. So notice we changed the grouping symbols here for these sums, and yet they are still equal. So let's practice these properties. The first problem here says rewrite using the commutative property of addition. So we're going to rewrite the sum 5 plus 9 using this property. So 5 plus 9, we're going to change our order and not change the result. So we have 9 plus 5. So this uses the commutative property of addition. We can change our order, not change the result. We're not going to work through this sum right now, we're just practicing with using these properties. So the second problem here says rewrite using the associative property of addition. We have 2 plus 1 inside parentheses plus 6. We can rewrite this as 2 plus inside our parentheses 1 plus 6. So we changed our grouping symbols for these sums, and yet they're still equal. So let's move on. Now let's use these properties to find a sum. So the first, we're asked to use the commutative property to find the sum of 2 plus 4 plus 8 plus 6. Now remember that the commutative property says that we can change the order of any 2 numbers in a sum and still have the same result. So looking at these numbers here, I'd like to change the order and group them. Let's see. Let's pull the 2 down. I want to move the 8 over here. I'm going to move this over here. And then let's pull the 4 here and pull our 6 down. Now these numbers are a little bit easier to work with because I can tell that 2 plus 8 is 10 and 4 plus 6 is 10. So 10 plus 10 gives us a sum of 20. So by changing the order of these numbers here makes the math a little bit easier to work with, and we know now that the sum of 2 plus 4 plus 8 plus 6 is 20. This problem here asks us to use the associative property to find the sum. Now remember, the associative property says that we can change the grouping of 3 or more numbers in a sum and not change the result. So first we have 4 plus 3 inside the parentheses plus 7. I'd like to change this. Let's move our parentheses to the last two numbers. So this is the same as if we were to write 4 plus 3 plus 7. Okay, so now inside our parentheses we know that, bring down our 4, 3 plus 7 is 10. This math is easy. 4 plus 10 equals 14. So our sum of 4 plus 3 plus 7 using the associative property is 14. Now this is the same just to go back and say if we were to do the math here, 4 plus 3 is 7, and then 7 plus 7 is 14. So you can see that no matter which way we were to group these numbers, we'd still get the same result. Now we're going to move on to the value of an equation. We can use addition with whole numbers in order to solve simple equations. Let's say I were to ask you to solve this equation, n plus 6 equals 10. I'm actually asking you what number do you add to 6 in order to get the sum of 10. Now we know based on our addition facts that you can add the number 4 to 6 to get 10. So I can rewrite this as a true statement. 4 plus 6 equals 10. The value of 4 for n is our solution to this equation. Now looking at this equation, figuring out what n represents in order to get our sum, we solve that equation by means of inspection. So now let's move on to our last topic. We're going to see how we can use addition with whole numbers in order to solve problems dealing with perimeter. Perimeter is the sum of all of the lengths of the sides of a closed geometric figure. So we have two figures here that we're going to work through and find the perimeter. Let's work with our rectangle here first. Now we know that if this side says it's 3 inches, we know that the other side just opposite it is equal in length, which is 3 inches. Same goes for this side here. If the top one is 10 inches, this side down here is also 10 inches. So we can find the perimeter by adding up all of these lengths. P is equal to 3 plus 10 plus 3 plus 10. Now we'll do our math. 3 plus 10 is 13, plus 3 is 16, plus 10 is 26. Add in our inches, which is our units. So our answer for the perimeter of this rectangle is 26 inches. Now for our triangle here, we have the values for all three sides. So let's add them up. We have 4 plus 9 plus 12. Do our math. 4 plus 9 is 13, plus 12 is 25. And our units here are centimeters, so we'll add that to our answer. Here we go. So the perimeter for this given triangle is 25 centimeters. So perimeter is a real-life application for addition with whole numbers.